Okay, so equations of ellipses, it's the other part of 7.2. And ellipses are a little bit more complicated than circles. But you're gonna find that it's similar in difficulty to the equations of parabolas that we had been dealing with earlier this week. So with that, time for notes. 7.2 ellipses. Okay, so an ellipse is basically a circle that someone took and squashed, or that's what they look like. There are kind of two different ways that ellipses can be oriented. You can have one that's kind of like this, or you can have one that's elongated this way. Ellipses have a center, and it's still using that HK notation that we used for circles. So the center of an ellipse would be there. And ellipses also have something called foci, so it's the plural of focus. So the foci would be like here on an ellipse. And they have different equations depending on which orientation of the ellipse you have. So we're going to leave it at just calling them foci for the moment until we can talk about the orientation of the axes. Then they have two different axes. They have the major axis, and the major axis is the longer axis. So on this one, it would be horizontal. On this one, the major axis would be vertical. And then we also have the minor axis, which is the shorter axis. Okay. And there's usually, well, we'll talk about what exactly vertices and co-vertices are in a moment, but that's kind of the gist of what we're looking at with an ellipse. Now, let's kind of take apart our two different cases here. We have the vertical major axis and the horizontal major axis, and they both have different equations going on. So first, we're going to start off with the vertical major axis case. Okay, so if your major axis is vertical, here's your equation. We have y minus k squared over a squared plus x minus h squared over b squared equals 1. Okay, so that's the equation that we're working with. So you might notice that this looks very similar to our circle equation. We have, x minus h and y minus k. They're both squared and added together. But then we have these a and b values that we're dividing by. So that's what makes it a little bit different than a circle. We also notice that this is not just r, but it's 1. But if your a squared and your b squared value are the same, that does mean that it's a circle. So it's kind of a variation of a circle, which we see in the shape. Anyway, so some of the parts of this and things we can find from it, if we've got a vertical major axis and we've got it looking like this, along the major axis, the top and bottom points here are called vertices. And then we have the center, which is still HK. And this distance between the vertices is 2a units long. So that's where the a comes from. And then we also have these things called co-vertices. on the minor axis, and the distance between your co-vertices is 2b units. And since we know that the center is hk, we can come up with equations to find the vertices and the co-vertices here. So the vertices are going to be on the major axis, and they're h and then k plus or minus a. So this one would be k plus a, this one would be the k minus a. And then for the co-vertices, those ones are going to be on the minor axis, and it's h plus or minus b k for their coordinates. Okay, so now we have the major axis, the minor axis. We have the vertices and the co-vertices. Next, we do have to talk about the foci. I told us up here that we were going to talk about them, but in terms of the different shapes that we had, whether it was the vertical major axis or the horizontal major axis. So, the foci are an equal distance away from the center. So one is, we're going to call this distance c. So the distance between the foci is 2c. And so the foci are located at h and the k plus or minus c. And the way that we calculate c is using something that looks kind of like the Pythagorean theorem, but it's not. It's a squared minus b squared equals c squared. So instead of a squared plus b squared equals c squared, it's a squared minus b squared equals c squared. Okay. And then the equations of the axes, the major axis is x equals h, this line here. The minor axis is y equals k, this line here. Okay. So if we were kind of pulling apart this equation, this is where everything comes from, what everything is called. Now what we want to be able to do is take an equation or take a graph and figure out where are the vertices, where are the co-vertices, where are the foci, what's the major and minor axis, what's the length of the major axis or the length of the minor axis, and stuff like that. So let's start with a problem like that. Then we'll move on and talk about what if the major axis is horizontal. So first example, we're going to take the equation y minus 1 squared over 25 plus x minus 2 squared over 9 equals 1. And we are going to graph it. And we are going to find the center, vertices and co-vertices. We'll find the foci and the length of the major and minor axes. Okay. So if we are going to graph this thing, first off, we notice that it's got a vertical major axis because the equation takes this format here, where the number, you can actually tell because the number underneath the y minus k squared is larger than the number underneath the x minus 2 squared. So this being the larger number tells us that we've got the vertical major axis. That's another thing that I guess we could note up here. A squared will be greater than b squared. Okay. So if we're going to plot this thing, we want to figure out kind of what are our step one, figure out H, K, A, B, and C. Okay. So looking at, one moment. Okay. So looking at this, H and K are found just the same way that we found them for the circle. We had K is going to be 1, and H is going to be 2. Then finding A and B is simple enough. A squared is equal to 25. So that tells us that A is 5. B squared is equal to 9. So that tells us that B is not 9, 3. Then lastly, to find C, we're going to use our equation A squared minus B squared equals C squared. And we know A squared is 25. B squared is 9. 25 minus 9 is 16. And the square root of 16 is 4. So C is going to be 4. I realized I spelled vertices wrong. It's supposed to have a T in it. All right. Anyway. Okay. So now that we found H, K, A, B, and C, now we need to figure out the center, the vertices, the co-vertices. We can start finding all of those things. So 2, now we need to plug those values in. So the center is just HK. So that's going to be 1, 2, or sorry, 2, 1 in this case. The vertices are H and then K plus or minus A. So in this case, we're going to get 2 values. We're going to get H is 2, and then K is 1, plus or minus 5. So 1 plus 5 is 6. 1 minus 5 is negative 4. So these will be our 2 vertices. The co-vertices would be H plus or minus B, K. So in this case, that's going to be, let's see, H was 2 and B is 3. So 2 plus 3 is 5. And then 2 minus 3 is negative 1. So these would be our 2 co-vertices. And then lastly, we need to find the foci, which are H, K plus or minus C. So we get 2, and then K was 1 plus or minus C, and C is 4. So 1 plus 4 is 5. 1 minus 4 is negative 3. And now we're ready to graph. So I'm going to start my graph over here. And let's see, knowing that we're dealing mostly with things on the right-hand side. Okay. 1, 2, 3, 4, 5. I think 5 is the farthest we go over. 3 looks like the farthest, no, 4 is the farthest that we go down. We go up 6. And then we go over -1 only, I believe. Okay. So now we're ready to plot things. Starting with the center at 2, 1. So over 2, up 1 is our center. The vertices are at 2, 6 and 2, -4. The co-vertices are at 5, 1 and -1, 1. And really that's all that you need in order to graph, because now it's kind of connect all of your vertices. If we're graphing by hand. And maybe yours will look more ellipse-like than mine. We do try to make these look somewhat equal, but you know, drawing's hard. And then the focus, the first focus will be at 2, 5. And the second one is at 2, -3. So those would be our foci. Okay. And then if we wanted the length of the major and minor axes, the length of the major axis is this distance here. It's 2 times a, so that would be 10. The length of the minor axis would be this distance, or 2 times b, which would be 6. Okay. So if we were given an equation, this is everything that we could determine from that equation. And pretty much it's a lot of plugging and chugging. Any questions from this so far? Any numbers we're not sure where they came from? Steps we're not sure how they happen? Okay, then. So that's if we have a vertical major axis. Now let's take a look at what happens if we have a horizontal major axis. Because the equation is very similar, just ordered a little bit differently. So this time we've got a horizontal major axis. All right. So this time we have it looking like this. This distance is 2a instead, and this distance is 2b. We still have vertices and co-vertices, but this time these would be the vertices and these would be the co-vertices. Our equation this time is going to look like x minus h squared over a squared plus y minus k squared over b squared equals 1. So we know that we're dealing with the horizontal major axis situation when we have x minus h squared being over the larger number on the bottom. So again, a squared is going to be greater than b squared, and that's how we can tell which case we're dealing with. Okay, so this time our equations for the vertices and the co-vertices, it's a little bit flipped around. So this time it's for the vertices. So that would be those, is going to be h plus or minus a, k. Then the co-vertices, This time these are going to be h, k plus or minus b. So that would be those. The center is still hk. The foci will be h plus or minus c, k. And we still have a squared minus b squared equals c squared. So a lot of this is still, it's very similar. It's just switched around a little bit, kind of like on our parabola equations when we had it opening up and down versus left to right. Just a little bit different in that regard. So, second example. We're going to have x plus 2 squared over 16 plus y minus 3 squared over 4 equals 1. And we're going to do exactly what we did with the last one. We're going to find h, k, a, b, and c. We're going to find the center, the vertices, the co-vertices, the foci, the length of axes, and we're going to graph it. Okay. So for this one, I'm going to have you guys go ahead of me here and find h, k, a, b, and c. So go ahead and find those things, and when you think you've got them, type "got it" in the chat. All right, a couple of us have it so far. We'll wait another minute and then we will move along. All right, so what did we get for our center, h and k? Yeah, -2 would be h and 3 would be k. So that would be our center. What do we get for a and b? Yes, 4 and 2. Because we take the square root of 16 and the square root of 4. So then what do we get for c? 2 root 5. Yeah, because so a squared minus b squared equals c squared. So that's where we take 16 minus 4, which is 12. And if you take the square root of 12, actually it should be 2 root 3, I believe. Because if you divide by 4, you get 4 and 3 is what that breaks into. And then square root of 4 is 2. Square root of 3 is square root of 3. So I would leave this, as 2 root 3. It doesn't really help for like graphing purposes very much to have something like that, but that is the way that you'll see it in IXL and be asked for it in IXL as a simplified root. So that is important when you're dealing with finding the foci for the equation. So the next thing we want to do is find those vertices. So the vertices, h plus or minus a, comma k. So h is -2. -2 plus 4 is +2. And then k was 3. And then -2 minus 4 is -6. Still 3. And then the co-vertices, that would be h and then k plus or minus b. So -2. And then 3 plus 2 is 5. 3 minus 2 is 1. The foci, the way that we write them is going to be a little bit weird. It's -2. Really, you could write plus or minus 2 root 3 since you're still leaving this in exact form, but you could also split it up and write it as plus 2 root 3 and then k, and then -2 minus 2 root 3. Or you could write it as -2 plus or minus 2 root 3. And then let's see. I think that's about everything we needed. If you wanted to put down the length of the major axis, that's 2 times a, so that would be 8. And then the minor axis, 2 times b, which would be 4. But having this, we have plenty of information to graph it. So that's what we'll do next. Let's see, we need to go out to 2 in this direction and then 6 in this direction. And we need to go up 5. I think that's all. Okay, so our center at -2, 3. And then our vertices at 2, 3 and -6, 3. And then the co-vertices at -2, 5 and -2, 1. And then from here, we can really just draw the graph. And then I have just drawn a weird eye. Then finding the foci is a little bit more difficult on this one. Because graphing things where you have an exact value here, you can kind of, if you really want to draw it on a graph, you can approximate the value by figuring out, -2 plus 2 root 3 in the calculator, which is about 1.5. So we'd go over about 1.5, up 3. And then -2 minus 2 root 3 is about -5.5. So it would be somewhere around here for your foci. Alrighty. So there's that one. Any questions with this one? Any numbers we're not sure where they came from? Any steps we want to go back to or anything like that? Okay. Then, the next thing we need to do today is, now that we've been able to analyze the equations and the graphs and all of that, now we need to be able to be given certain pieces of information and make an equation out of it. So you might be given a graph, that's probably the easiest scenario, and make an equation out of it. You could be given like the foci and the length of one of the axes. You could be given the vertices in the foci, things like that. All of these will help us to make an equation. So we're going to do a couple of examples with that. So for this one, we're going to be given, I think we'll go with the vertices and the foci. So the vertices are going to be at 3, 4 and negative 5, 4. And the foci are going to be at 2, 4 and negative 4, 4. And from this, we want to be able to find the equation for the ellipse. So the first thing I like to do, if you're good at visualizing, you can kind of tell what the orientation of our ellipse is going to be. But if visualizing is kind of difficult, I would just graph these points really quick to figure out what we're dealing with. So we have the vertices at 3, 4 and negative 5, 4. So I'm going to draw myself a graph here. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4. So there's one and there's the other. The foci at 2, 4 and negative 4, 4. Okay, so that tells me that we're working with something in a horizontal major axis orientation. So that means we're going to have x minus h squared over a squared plus y minus k squared over b squared is kind of what we're working with here. Okay, so that's what we should be thinking. And we need to find h, k, and b. And so there's a couple of things that we can do to kind of help us with this here. First of all, we know that halfway between the foci is where the center is, and also halfway between the vertices. It's the same location. So halfway between these guys is going to be where the center is. So the distance between these, well, this is over at 2. So 1, 2, 3, 4, 5, 6. The distance between the foci is 6. So if I start at one of them and go over 3, that's going to be my halfway in between point. So my halfway in between point is my center, which is at negative 1, 4. So that's h and k. So that's the first part. We found h and k. And the things we are looking to find here, h, k, a, and b, because we need all of those in order to figure out the graph. We'll also need to figure out what c is, because in order to find b, we need c. But anyway, we found h and k. A is half the distance between the vertices. Because if we remember up here on our picture, this distance between the vertices was 2a. So half of this distance will be a. So this one is over here at 3, 4. This one is over here at negative 5, 4. So the distance between these is 8. So that's 2a. So that tells me that a is 4. So now we have a. If we remember back to when we were looking at the vertical major axis, I labeled it on that picture. The distance between the center and the focus is c. That still holds true on one that's oriented horizontally. This distance here is c. So c is 3. So we found c. Now we just need to find b, and we're in business here. And we still know that a squared minus b squared equals c squared. So 4 squared minus b squared equals 3 squared. So 16 minus b squared equals 9. Nine minus 16 is -7. So negative b squared equals -7. So b squared equals 7. So b is the square root of 7. So now, bringing it all together, we have h, k, a, b, and c. The only ones that we really need to write our equation with are those first four, h, k, a, and b. C is only necessary to help us find b. So here we go, putting it all together. X minus h, well, h was -1, minus -1 is +1. And then it's over a squared. A was 4, and 4 squared is 16. Y minus k would be y minus 4. And then it's over b squared, and b is square root of 7, so b squared is 7. And then equals 1. That would be our equation in standard form for this ellipse. Okay. So looking at that one, is there anything in particular that we're not sure about? Any numbers we don't know where they came from? Steps we don't know how they happened? Okay. Then let's do one from a graph, since that's the simpler case as well, and you'll see quite a few of those on your homework tonight. And then we might do one other kind and call it good for today. Let me double check and make sure that I get all of the ones that you have. Okay, so they give you the even easier ones. That's nice. Okay, so here we go. Let's do one with a graph. All right, so for this one, we're going to go over 2, 1, 2, 3, 4. There's our center. Two, 3, 4, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6. All right, there's a very special looking ellipse. Because as you can see, I'm wonderful at drawing these. The center is at 2, 4. This point is 10, 4, negative 6, 4, 2, 1, 2, 7. And we want to write the equation of this ellipse. And so doing it from a graph is actually even easier because all we need to find is h, k, a, and b. And we can find all of those just by looking at the graph. This distance here is a. This distance here is b. And these are h and k. Since this is in a horizontal orientation for our major axis, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. In hindsight, this is probably the kind we should have started with because this case is definitely simpler than the vertices and the foci case, but oh well. This will seem much easier then. So x minus h, well, we know h is 2, so x minus 2 squared. And then the distance here for a, well, we're at 2, 4 and going out to 10, 4, so that distance is 8. So 8 squared is 64. And then y minus k would be y minus 4. And then this distance for b, well, we're at 2, 4 and going up to 2, 7, so that distance is 3. And 3 squared is 9, and then equals 1. And we're all done. So as we can see, finding it from the graph is quite a bit simpler than finding it from the vertices and the foci, but both can be done. Any questions for this one? Any numbers we don't know where they came from? Okay. Then the last kind that we're going to do, because that should be an example of each type of problem that you will see on your assignment, is going to be one where you're given the vertices and the co-vertices. All right, so our vertices are going to be negative 8, 0 and 8, 0. And the co-vertices are going to be at 0, 5 and 0, negative 5. Okay, so when I'm given information like this, just like we did when we were given the vertices and the foci, I would always draw a little graph of things first just to see what's going on here. So that's what we're going to do. So we have negative 8 and positive 8, 5 and negative 5. All right, so our vertices are at negative 8, 0 and 8, 0. Our co-vertices are at 0, 5 and negative, or at 0, negative 5. So our ellipse is going to look something like this. And that might be the best ellipse I've drawn all day, even though it still looks like a weird lumpy potato. But anyways, we get the picture. We still need to find H, K, A, and B to do this one, but we don't need to find C because you can find A and B from the picture that we've drawn. So first off, let's find the center HK. We know that the center is going to be halfway between either our vertices or our co-vertices. So if I draw a line from vertice to vertice and co-vertice to co-vertice, where they cross is the center. Or you can also do it as halfway between the two. Either way that you decide to do it, we notice that our center is the origin in this one, 0, 0. So that would be HK. We also notice that we're still dealing with the horizontal orientation here. So x minus h squared over a squared plus y minus k squared over b squared equals 1. So then finding a and b becomes just like it was up here in this case. This distance here is a, and it just happens that that distance is 8. And this distance here is b, and that distance is 5. So plugging everything into our equation, x minus h, well, h is 0, so we can just leave it as x squared. And then a squared would be 64. And then same thing, y minus k, but k is 0, so we can just leave it as y squared. And then b squared would be 25. Okay. So we've now gone over at least one of every type of thing that you're going to see today. So looking at these, are there any examples that we want to go back to? Any numbers we're not sure where they came from or anything like that? Okay. Today's homework assignment is another IXL thing. So let's go ahead and take a look at it together real quick. So I'm going to post it. We have IXL P7 and P9 today. Might have to refresh the page. The first one is properties of ellipses. A squared plus b squared equals 1. It's the thing over a squared is and b squared is 1. So I don't think. Does that mean that c squared equals 1 as well? If a squared plus b squared did equal 1, then if you're working with a right triangle, c squared would be 1. But I don't think, I mean, we're working with something that looks like the Pythagorean theorem, but I don't think that that quite is what happened in the problem we just did anyway. Interesting question, though. Anyways, for P7, you're going to be asked for things like you'll be given the graph or you'll be given an equation and asked where's the center. So on this one, pretty simple, 0, 0. Or what are the vertices? So remembering that these are the vertices and that these are the co-vertices. So you'd put in for the vertices, since it asks for those, 6, 0 and negative 6, 0. Let's jump a level, see what we get next. All right, so we're still asking for things like the vertices here. It's just moved around off of the center being at 0, 0. Or what are the vertices here? So it'll give you the equation and you're asked for the vertices. So just like what we were doing in our first couple of examples. Or asking then for the co-vertices. Yeah, so pretty much all of this is exactly the kinds of things that we were doing in our first couple of examples. So that's all about P7. And then P9 is more what we were doing in examples 3 through 5, where it shows you a graph and you write the equation. Or again, a graph. Or it'll tell you the vertices and the co-vertices, just like in example 5, and you get to find the equation. Keep in mind when you're using this sort of thing, if you want to write a fraction like you're going to have to for most of these, click this first and fill in the boxes rather than try to format it on your own and then click this, because then you just end up having to retype stuff. Or it'll give you the foci and the vertices just like we had in example 3. And all right, that takes you all the way through to where you'll need to get, because we're getting to smart scores of 80. Okay. At this point, you guys are free to work on this on your own. I will post an exit ticket in a little bit. If you have questions or you want to do some more examples with me, feel free to stick around. Otherwise, have a wonderful weekend.